Hello, welcome back. Today we are giving the people what they want, another game dev video. I've been working on a cute little fishing game in Godot since I think about October of last year, and it's been kind of off and on in terms of progress because I've got a lot of other things going on, but in the past month or so, I've really been able to bust out a lot of the things that I think are going to make this game fun. And that was the goal, is to do the fun stuff first, so I have a game, and then sort of build the rest of the game around that, and try not to get too deep into development with this one because my last game that was not released, I think just got a little bit off the rails because I was working on it for so long, and over time I let the vision get a little bit cloudy. And what we're going to talk about today is my favorite feature so far. It's the fishing mini game, and it's a rhythm game, kind of. I haven't added any music. I probably will at some point, but I haven't decided if it's going to be like a lot of varied music or just like, Dredge kind of does a rhythm-based thing, except it's just like a ticking of the line being rolled in, reeled in, reeled in. So I haven't decided what I'll do there, but I have the minigame working, and before we go into the how of it, let's just see what it looks like. And something funny I realized as I was testing for this video is that if I make the screen big, it does scale the UI, which affects the timing, which makes the game harder. So I'm going to keep the screen little because this is how I'm used to playing it. I am going to have to fix that so that the speed of the dots is not different if you're playing it on a bigger screen, because that's wild. Alright, so the way that we do this, we get our fishing rod out, we cast into this little thing, and then I probably need to make this transition automatic, but for now we do have to press interact again to start this little mini game, and we can press the dots as they come down. Alright, there we go, that's how it works. Then we get our fish. And the interesting thing is that as I was approaching the minigame portion of the fishing feature, I actually wasn't going to implement like a real solution. My plan was to just make something simple, like you press a button, and just to get the flow of everything in the game, because that can be tricky sometimes if you have things working a certain way and you want to add like an intermediate step, or you want to pass control of the progress to a different system. Like for example, this, I'm passing control of the fishing state to the minigame and then sort of giving it back at the end. That can be tricky, so I like to get those things set up first so that everything's kind of working, and then I can polish it up and add details and things like that. However, as I was starting on this feature, YouTube decided to give me a video from Jace Varlet, I think that's how their name is pronounced, another YouTube game developer who uses Godot, and they made a rhythm game for their RPG. Theirs is karaoke based, it's got the arrows, it's very similar to DDR, so it's a little bit different, but when I saw it and I watched the video, it's a good video, I would recommend it. I was like, maybe I do want to just make this right now. We have Jace to thank for that, for showing up when I needed it and giving me that little push. So let's get into the actual implementation. So when I started, all I had was this system where you cast into the fishing node, you press to reel it in, and it reels it in, and it's just automatic. There's nothing you have to do to progress from, fishing to catching a fish. It would just give you a fish. Nope, no questions asked. So the first thing I had to do was sort of add that plumbing. And the way I've done this, I've made the text big. Hopefully you can see it if you want to see it, but I'll just say this is not really a tutorial. You won't be able to sort of follow this step by step to make your own rhythm fishing game. This is more just to show you how I did it and give you some ideas for how you might do something similar in your game. So, and actually it's kind of hard for me to read where I'm at in the code when it's so big, because I don't work like this. The first thing I did was create a new class, which I have creatively named Fishing Minigame Runner. And this is going to be in charge of running the minigame, as you might guess. And so first things first, this minigame runner has a state. This is just an enum. It can be stopped, running, or in the results phase, and then it sort of cycles through those phases or these states, depending on what's happening. So we have the state here. Let's not worry about all this stuff for now. And then we do have an event here, and I'm just using C# events. I know that with Godot you can define signals and connect those up to different things. I'm just not really familiar with that. I did one signal, and then when I went to do another one, I couldn't remember how I did it, so we're just using plain old C# events on this one. But basically, when the state changes, it gives the new state, and then it gives a score. If it's not a result phase, this just won't have anything in it. The score will be empty. But this is what it is. So when we start the game, for example, we update this to rhythm game running, and we emit that score again down here. When we're done and we're in the results phase, and we press the button again, this sends us to the stopped. This is kind of out of order. This would come after the results. But then here, whoops, there. When we need to stop the game, and this is called when the duration time has elapsed, we go to the results and we send that event. So no matter which state we're in, it sends out this event. And then the fishing feature, which sort of handles which state the player is in and like what they should be doing, it calls into the character controller and makes sure the animations match up and all that. This gets this state, and if it's in the results state, we connect this to the fishing features results state, which currently shows that little tooltip with the fish info and has the player like holding up the fish like this. And then here's where things get a little bit different. Now the score has to be above 0 to actually get the fish. So this is the code that stops the fish from swimming animation and puts them up into the player's hand. Otherwise, we just like let go of it. There's no fish anymore, it's gone. And then we just have some normal fishing state stuff there. And another thing that I had to do here was take out, I believe it was in the process of the fishing feature, if we were reeling, it would automatically transition to the next state when we got past like 2 seconds of reeling. So I've just ripped that out. So now we get into the reeling state, and it just stays there until it is transitioned out, which happens here. So pretty simple changes to the fishing feature itself, which is how I like it. I don't like to get too crazy with my changes. I like to try, I'm not perfect at this, but I like to try and design things so that they can be connected to different systems without having to like overhaul either side of the equation. Now the next thing I had to do was actually decide what I want this minigame to look like. And so I started this process on paper, but basically I drew out some things that I was thinking. I took a lot of inspiration from Dredge because that currently is one of my favorite fishing games. I just think it's really good, and then also specifically I think the mini games are very like tactile and satisfying. I think they're like involved enough to keep you interested, but they're not so complicated that you're annoyed that you have to do them throughout the game. I feel like they found a really good balance there. So I was kind of thinking of what can I do that's kind of quick but still interesting. And then I had this idea that I wanted to do a rhythm game. That's really been in my brain since I started making this, just because I really like rhythm games. That's just a me thing. And then all these different things pushed me over the edge to actually do the rhythm game. So if you haven't seen it, I did do a whole video about how fishing is handled in different games and just why I really like fishing in games and what makes it fun. So you can check out that video if you'd like to, but that was where I got a lot of this information. I did that research probably months ago at this point, and I collected it and I thought about it. And what I ended up coming up with was, as you saw, because you saw the finished result, was this 3-lane system here. And the idea that I haven't hooked this up yet, but the idea that I had was that these would be tied to directions. So A, D would be left and right, W would be like up, or kind of thinking of like pulling the rod back was kind of what I was thinking. So in the long run, I believe I want each of these buttons to correspond to the player like pulling the rod or other fishing implement. I have some ideas for that in a certain direction. So it's kind of it's grounded in the reality of the situation, which is that you're trying to catch this fish and it's going all over, and you gotta meet its movements with your own movements is kind of the theory behind this. So this is what I kind of sketched out. I had some other things. I had some spinning things in mind. I had sort of I don't think I've talked about this game on YouTube yet, but I have played it a couple times on stream. But I was thinking about the Headbangers Rhythm Royale game with the pigeons. There's a couple of mini games that I really like in that one, so I was kind of looking at those and thinking, can I do anything with these? And ultimately, I landed on this, which is a pretty traditional rhythm game format. It doesn't have arrows, but you know, it could. It's almost the same exact idea. But I am reserving the potential for adding different kinds of games, because I was kind of thinking of adding different tools. And then each tool would have a different mini game that sort of fits what it is, but we'll think about that later. That's sort of a stretch goal. We want to get this working first. And once I had the plan, I had to think about how am I gonna actually build this, because I haven't really done a lot with 2D elements in games, especially when for rhythm games, it's very important that the timing is correct. So we want to be able to display the dots on the lanes and have them slide down the lane and meet the sort of target zone at the exact time that we want the user to press a button. So there's a lot going on here, and I really had to think about how I was going to accomplish this, and this is what I ended up doing. Again, I just want to say, for all of these videos, I am still learning Godot. There's a big possibility that there's a better way to do the things I'm doing, but this is what I tried, and this is my thought process, and this is what worked in the way that I needed it to work. So don't be too harsh on me, and also don't take my words as 100% complete the best optimal way to do things, because it's probably not. But this is how I did it. I decided first of all that the minigame runner would be the source of truth for timing, and it would control what is displayed in the UI. And this, I think, is a good way to do most things, is to have a code backing for things that are visually displayed, so that you always, well, first of all, it makes it easier to test, because you can test the values going into and coming out of a piece of code much easier than you can test whether things are being displayed or animated correctly. It's just easier. So that's one reason, but also it just makes it a little bit cleaner to design when you have the sort of algorithm in one place, and then the visuals are only responding to that algorithm, and they aren't calculating their own things, if that makes sense. So it makes it easier to test, and in most cases it makes it easier to design as well. Alright, so some of the places we manage timing in the minigame runner. First of all, the duration here is currently hard-coded. I'm going to do some things where I'm going to be able to pass in values, for example, for duration, for speed, for how complex the dots should be, the patterns that they have to match. For now, it is hard-coded just to get it up and running. We also have this miss ms variable, which is basically how much you can miss a dot by in terms of times. This is milliseconds. I do everything in the minigame I do in milliseconds, because I figured that's granular enough to be, kind of accurate for stuff like this. We keep track of score and the time in like system milliseconds that the minigame was started. And I'm gonna need to, if I'm gonna let the user pause during these, which they probably should be able to, I'm not sure. I'm gonna need to figure out how to handle pausing, but I haven't thought about that yet. And so when we start the game, we reset the score and we get the current milliseconds that we're at for the time started. So from here, it uses this as the starting point, and all of the buttons are calculated from this starting point. And so that's sort of how I'm handling that. And then the first thing we do is actually we do generate the buttons. If this was a more traditional rhythm game, which was connected to a song, you would want a way to design the maps so that the notes match up with the beats of the song and the melody of the song. Currently, I'm not concerned about that. I don't even know if I'm ever gonna do that. I think maybe I will just come up with a BPM that all of these mini games are gonna follow and just generate them based on that. But who knows? We'll see. But for now, we literally do just randomly generate a map for each run. But I'm just going through 500 milliseconds at a time, and I'm generating a random number. If it's 1, I add, I think this is the left button. Yeah. If it's 1, I add a left button. If it's 2, I add an up button. If it's 3, I add a right button. And if it's nothing, I don't add any button. And I do have this check in here because I was getting some that were completely empty, just like randomly getting 4 every time, or 0 or whatever this is. I did add this check where if the button list is empty, we just add a left button. And I'll figure out how to tweak these things later, but I wanted to make sure for these little tiny test sets that I was actually getting a couple of buttons to press in the game. So that's how I do that. And then the rhythm game starts running. And so we have this set of buttons generated. We have time passing. And what we do from there, we'll skip through all this. First of all, if it's not running, we don't do anything in process, just to save our, save the effort here. If it is running, we first get the time elapsed from that time started. This is sort of the offset of the buttons. So, for example, we want one button to be hit at 500 milliseconds after it starts, or 750, or 1250, So we want to get the offset. And then we go through this list, which is basically the map. And the way that I've done this, I think is kind of clever, is that instead of starting at 0 every time, I only start at the next button and I've called these buttons. They really shouldn't be called buttons. You don't press them with the mouse, but whatever. But I start with the next one that has not already been spawned. So I'm skipping all the portion of this map that I don't need to look at. I get a reference to it, and I check if the time that's elapsed is greater than the time I set as the time it should be pressed. And if it is, I spawn it. And then I advance to the next button, and we add that to the button on screen. And then we use this event to talk to the UI, which I'll talk about in a moment. Otherwise, we do actually break out of this. So this, I'm hoping, will be, performant enough. We're not checking every single available button every time. So they do have to be in order. That is critical to this function working, is that you can't put the buttons of the map in a random order. They have to be in order of time, or this won't work. But the way it is, it should hopefully loop through only the very next buttons and check those and spawn any that need to be spawned, and then it'll advance. And then here, we do check of all the buttons that are on screen, we do check if they have finished their trip down the lane. So here we check if the time elapsed is greater than the amount that the time they're supposed to be pressed at, plus the time it takes them to get down the lane. And then I've just added double the miss amount to give it a little bit of wiggle room there. After that, we tell the UI to get rid of it. And then we get rid of it here. Okay, easy enough. And then at the very end of process, if we have reached our duration, we stop the game, which sends us to the results screen. So that's basically the whole thing. Where is this? There we go. So that's basically the whole thing. We generate the buttons, we spawn them at the right time, we remove them at the right time. But with all that code, you won't actually see anything because it's not hooked up to any UI on this side. It has to have something listening to these events that will actually create and remove the buttons on the UI. So that's where fishing minigame view comes in. And before I talk about the code, I am going to talk about the structure of this UI hierarchy. And I'm just, disclaimer, I'm still learning the Godot UI system. It seems it seems like you have to create a lot of elements to get the look you want, and I'm not sure if I'm doing this correctly or if there's a better way to style this stuff and structure it. But this is how I've done it, We do our best with what we have. And the way that I have this set up is that, first of all, it's all in this panel. This panel currently sizes itself based on the screen size. I'm gonna have to probably change this so that it is a consistent size on most screens, because otherwise the timing's gonna get messed up, which is what I mentioned at the beginning that I noticed. I just have this little label. I don't know why I put this here. It doesn't really add anything to the game, but I'll jazz all this up later. And then I have all the stuff in this control, and this is separate from this control so that it can overlap, I think was my thinking on that. But in here, I have plain controls for each lane. So the reason I have these as plain controls and not as containers of some sort is because these elements, these plain controls, are where I create the little dots that go down, and if they were containers, they would try to position those. They would try to like force a position and a size on those, and I don't want that. I just want a space where I can create the little dot and then offset the Y value, the Y position, to animate it downwards. So I have the plain control up top, and then I have a container which I use to size these so that it's evenly in the middle, and it has the little panel in there for the color. And then all of these three things look the same. I'm just gonna get rid of them real quick because it takes up a lot of space in here. So this is actually fairly simple. The reason it's got all this crap in here is just so I could size things and position them and have them automatically fit the space that they're given, which is what the containers are really good for. The way I understand it is that, that's how you respond to changing sizes in a responsive way. And then I've also created prefabs or scenes, I guess, for each color of button. And the way that these are positioned are that the top level is sized based on its parent to take up the full width. So here it looks a little silly because the full width is like the screen size, but in here the full width is just going to be this little lane box. So this is going to center the dot in this full width space. And then this is just a panel, but I have one of these for the blue, the green, and the red. So I don't have to worry about changing the colors in code or anything. They're just ready to go. So all of that is connected to the fishing minigame view code. So here I have the buttons. These are the buttons at the bottom that represent what you press when you want to press the dot. Let's see. I don't know what this is. Oh, I think, okay, so game control panel and results panel are the two top level controls for the actual minigame and the results, so I can show or hide them if I'm in different states. And then I have the left lane, the up lane, and the right lane. These are where I add the buttons. I have some labels for the results and the score. And then these are scenes. Those scenes I mentioned where I have the red dot, the green dot, and the blue dot defined. And then I have a lot of just kind of styling crap in here. Don't worry about all this. A lot of this is just for getting it to look the way I want at the right time. And then right here we do have a reference to the minigame runner, and we have a list of all of our active buttons. So this button with speed is an ID, which I use to retrieve buttons that I need to get rid of. I give them an ID. I also have the reference to the control, so I can uninstantiate it when it's done, or destroy it, or queue free, or whatever the right word is in Godot. And then I have the amount of milliseconds it should take to go from the top to the bottom. Okay, so here, I'm going to move this out of the way so we can have a better look. When we start this up, we first just get references to these various panels for styling purposes. We make a new list for these buttons. We subscribe to these events. So we have game, whoops. I hate these pop-ups popping up and interfering with my clicks. We have the game state event, which is when we go from running to results to stopped. And we have the button spawn event, which has, we'll just go here because it's right here. It has a thing representing which button it is and when it should reach the bottom, whether this is created or destroyed. So we can use this to destroy existing buttons as well, or dots or whatever. I gotta get my naming scheme straight. And then we have the score, which is when the button is being removed because it was successfully pressed, we want to show the score of that press. So if is created, we want to make a new button, a new control. We want to create that object that's going to hold the ID, the control, and the button time. And then for each of these, we check which type of button it is. If it's a left button, we get the left type of button, so the red dot. We instantiate that. We add it to the left lane. Same thing, green dot up lane, blue dot right lane. Everything there makes sense. Then we actually create our button object where we set that control node to the button control, and then we set the speed this button should descend at, and we add it to our list. Now, if we are removing this button, we do have to find it by ID. So we go through, you'll probably use like a link query for this, but I didn't. We go through, we get the button that matches the ID. And if the score is greater than 0, so this button was deleted because it was pressed and not just because it ran out off the edge of the screen, which we could also add like a miss graphic if I do an else here. But if we have a score, we do this highlight score, which just sets the border color based on how much it was hit by. If it was hit almost perfectly, it's like a white color. If it was hit like okay in terms of the delay, it's like a light gray color. And then if it was just barely hit within the time frame, you get a darker gray color. This is all pretty straightforward. And then if we did remove that button, if we found it in our list here, we just queue free and remove it from our list. And I think, is that pretty much everything that we have to do? As you are pressing the buttons, I guess I didn't cover this. As you're pressing the buttons, we do call into minigame runner to tell it that a button has been pressed. And that is what it uses to figure out if it should increment the score. So let me go back to fishing minigame runner. We're gonna go to right here, button pressed. So every time a button is pressed while the fishing minigame is running, is processed here. We get the time it was pressed based on the time started. So again, we're not doing anything with time in the view. We're only doing it in this backing code. And that's important for keeping everything on the same page. So we have the press time of the button relative to the start of the game. And then we can compare here. So the time we actually want to hit the button is this time pressed milliseconds plus the time it's going to take. I guess this should really say time spawned, but I'm kind of reusing this like data struct for a couple of different things. So the naming here is a little bit misleading, but this is basically the time we spawn the button plus the time it takes to get to the bottom, which is when it should be hit. Then we make sure that the type of the button that we're checking matches the type of the button that was pressed. So this makes sure that if we press the left at the same time that a right button reaches the bottom, we don't get points for that. And then we make sure it is within that miss window. You know, it's either plus or minus 300 milliseconds. And this is pretty forgiving, I think, though it depends on how quickly the things are moving. So we'll balance all this and make sure it's like challenging but not too challenging. If we hit the button within this range, then I get the diff, the how much were we off by. And I realized I had to check specifically if which of these was greater than the other, because with this unsigned long, if you try to get a negative number, instead it will wrap around to the maximum value. And that's not what we wanted. So if this number's bigger, we put that on this side of the subtraction, otherwise we put it on the other side. And so then we actually get the difference in milliseconds instead of just like a random number. This was a bug that kind of tripped me up because I wasn't used to using unsigned numbers for anything really. I don't think Unity used that. I think it just used a normal long. I could be wrong. But we get the milliseconds difference here, and then I've just sort of decided these ranges kind of arbitrarily. If we're within 25% of that miss window, we consider that like a perfect hit. If we're within 75%, we consider that like a good hit. And then if we're really close to the miss window, we're a poor hit, basically, or an okay hit. So there we go. And then once we've hit the button, we do call this button spawn event and tell it to get rid of it and give it the score. So that's the piece that connects there. Okay, and then literally all we do at the end is just show the score. We don't do anything to like figure out if it was good enough to get the fish, and that's one thing I want to add. There's a couple of things that I definitely want to add to this system that I just didn't get to in this video, but that's it. That's how the fishing minigame works. Right now, if I don't hit anything at all, and we just let these go to their death, we don't get the score, or we don't get the fish. We don't get a score either. It's 0. And we do hold up this pretend fish. I was thinking of keeping this the same and then just making her face look sad. So she's like, this is where I would put my fish if I had one. That's a thought that happens in my head, but I haven't committed to that yet. But if we go again, if we do hit at least one of these, there it is, we do get the fish. So in the future, what I want to do is I want to make, I don't know how I want to do this. I want to make some fish harder to catch, but I don't want it to be punishing. As long as you're paying attention, you should be able to do it. That's kind of what I want, and that's kind of how Dredge did it, where you could miss hits, and you could miss like the trophy fish, but as long as you were kind of paying attention, the worst thing you would do is waste a little bit of your day, and you would eventually get the fish. I don't know why I feel so strongly about that. I just really dislike when games are designed to be very hard and there are no ways to tune that to your own experience. Because I feel like as a developer, I can't design a game that's going to be just challenging enough for everybody. And I don't want to punish people for being bad at video games. I don't like that. I don't like that being a requirement of playing a game, is that you have to be really good at it. So that's kind of my philosophy. But I'm rambling. This is my fishing minigame and how I built it and some of the things that I thought about as I was building it. There's a lot of ways I can improve this system, but for now I'm moving on to some other parts of the game to kind of get a complete game loop going, and then I'll come back and I'll polish this up. If you thought this video was interesting or entertaining or just fun, please leave a like and consider subscribing if you would like to do that, because I'll be back soon with another video, potentially another game dev video, because I've been moving at a pretty steady clip, but I hope to see you there. All right, bye bye.